we are in very interesting times. There's a lot of talk about that. And I figured you're the best person to talk to because you are a rocket scientist.
Yeah.
Help me understand what is going on from the technical perspective of missile defense.
Technically speaking, also if we follow the Ministry of Defense publications, they every day share number of eliminated drones, ballistic missiles, and the cruise missiles. Air defense systems specifically objective to eliminate these missiles.
So it's amazing because the Ministry of Defense has published very impressive data as far as the success rates when it comes to our defenses here.
Definitely.
Could you talk to me about the multi-layer defense system that we have that's currently keeping us safe in the country?
Actually, these data Ministry of Defense shares about three systems, drones, ballistic, and the cruise missiles are important, and it is linked with the multi-layer system because a ballistic missile comes from very far, and the first layer, which usually it is THAAD system, THAAD air defense system, can able to detect the object around 3,000 kilometers away.
Right.
And then THAAD interceptor can eliminate the threat around 200 kilometers. So basically it detects around 3,000 kilometers. At the 200 kilometer range,
Right.
it eliminates. Let's consider if it doesn't eliminate, there is another layer,
Right.
the Patriot.
Patriot
The
missile.
Patriot can eliminate the target around 50 kilometers. So if one misses, the second one can be able to eliminate. So that is the system that the multi-layer defense mechanism.
What would you say accounts for the success rates of
Yeah.
our defenses here?
Having a perfect multi-layer system operational is really unique. THAAD has a 100% success rate. Eliminates the ballistic missiles.
That's amazing. That's
And
impressive.
for the cruise missiles and the drones, the other systems have more than 95% of success rate, which is great. And consider the things that couldn't, let's say, intercepted, actually intercepted outside of the city.
Okay.
So the debris, most of the debris fall to the desert of the sea.
Right.
Unfortunately, yes, some of the impacted some critical areas.
Based upon the success rate of our missile defenses, it's at around 95, they say, I think.
Yeah,
Don't quote me on this, but it's above 90%, I would say. What accounts for the 5% ineffectiveness?
Having an operation of multi-layer system with this success rate, it's great. And there are some challenges in engineering point of view and scientific point of view. For example, if you have a hypersonic missile or if you have some swarm of drones, which is multiple drones is coming through the target,
Right.
it's a bit critical to intercept.
Absolutely.
As well as the jammers. Imagine that there is a jammer is coming to distract your radar,
So
right?
This distorts the information.
You may have a misinformation and then that missile or drone can affect you.
Absolutely.
So scientific point of view, these could be some minor effects
So those are
that
just
should be improved.
very minimal challenges, that is what
Yeah.
you're saying, right? I mean, again, irrespective of that, at a plus 90% success rates, that's
Definitely.
impressive,
Yes,
tremendously.
definitely.
Right. Yeah.
The multi-layer system is so advanced. When you apply in these air defense system mechanisms, it combines the success rates all together, and then you have a total success rate which is really high.
What are the mechanisms in place that says, hey, we have this size of missile coming
Yeah.
in, let's deploy the THAAD or let's deploy the Patriot? What kind of mechanisms do you suppose it's been implemented in that situation?
That's the radar system of the mechanism, actually. For example, around 2,000 or 3,000 kilometer away, the THAAD radar can understand by using algorithms, thermal imaging, and
Okay.
measuring the speed of the object from the radar, can understand
Okay.
the speed of incoming object.
So that information is what determines what
Definitely.
system is to be deployed.
Definitely. If
Interesting.
this is a ballistic missiles, you can use THAAD interceptor. If it is a cruise missile, you can use Patriot, for example. So all ballistic and cruise missiles have a different trajectory profiles that is, traveling through the target or the drones.
Got it. What other challenges do you see in a missile defense system that could be significantly improved?
Generally speaking, air defense systems can able to detect objects from 3,000 kilometers away and can able to eliminate the object as an altitude of 150 kilometers, which is border of space, right?
Right.
However, there are some challenges regarding to sensor softwares and having a detection of these multiple targets. So basically, artificial intelligence based sensors and better mechanisms in these, let's say, we can call it computer systems of the interceptors, will be key in the future to improve.
So AI would play a significant role
Definitely.
in the improvement of...
Definitely.
Okay.
Especially if you want to detect the size of the object, right? Shape of the object. You can still, it's perfect. However, there will be challenges in the future that AI will help.
There are situations where you have a swarm of such objects that are targets in your location. Again, this is where economics does come in now.
Definitely.
We know that these defense systems are very expensive. How can we mitigate that challenge?
We have an example of THAAD, for example, THAAD air defense system. The battery of the THAAD, it includes 6 launchers, which is truck-based launchers. In each launcher can have 8 interceptor.
Okay.
So basically 48 interceptor, and including the fire control mechanism, the computer systems and everything, the radar as well, all packaged THAAD system cost $1 billion. So basically in every 48 interceptor, you need to pay $1 billion.
Right.
And one interceptor itself is $12 million. So it's including these 1 billion for sure. But
Absolutely.
how we can reduce this cost? There are a couple of perspectives. One is the propulsion system. Now these are the solid propulsion. If you change it, for example, hybrid propulsion based, you might reduce the operation cost, manufacturing cost, and logistic cost.
So it's a function of the materials.
Function of the systems, materials as an engineering point of view.
Which in fact means that if we can improve upon the materials of the system, then we could have much more cheaper.
These are all connected in engineering wise. If you have an mission profile from the space application, let's say, through the air defense systems, you can reduce the cost actually.
Absolutely. Okay.
Engineering.
So the thing to do would be to work on minimizing the cost of those of the system in order to better protect the localities, what you're saying.
Definitely.
Okay.
This is mechanical and propulsion point of view. And also there is another point of view, which is software side.
Okay.
AI-based systems might reduce the...
I would imagine it's already being used right now in defense.
Significantly,
Yes.
But there will be quite
much more advanced.
Much more advanced systems. Because if we have the quantum computers, then if you implement these quantum computing and cyber security applications to the defense systems, then you need to improve and upgrade your, let's say, computers.
Amazing. Hey, it's great talking to you. We've always had these conversations off the camera, and I thought it would be a good idea.
I'm sure the
finally have this conversation.
I'm sure the communities can have engineering and scientific perspective of
what's happening.
The systems, what's happening. It's amazing. Thanks you for the opportunity.
It's great. Always great talking to you.
Thank you. Likewise.